Graphing a derivative from the function is actually quite easy if you follow certain rules. I'll start with a function, a particular function here in blue, and this is a quartic function. So firstly, we need to establish where the maximum and the minimum points are. This is where you'll find the horizontal tangents at the maximum point here, at the minimum point here, and at the maximum point there. Then draw a vertical line to the next set of axes, going to show our derivative function. And do this for all the maxima and all the minima values. These points show you where the horizontal gradient is, or the horizontal slope is of each point. So therefore, these points will show you the zeros of the derivative function. And here we'll see our derivative function. Now, secondly, you're going to highlight the parts of the original function where the slope is positive or negative. And straight away, the slope is positive on this side because this part of the function has a positive slope. So I'll just color that in with this green. And the other place also that it is positive, all the way down to here, is when the slope goes up. It's between here and here. So I will also color that. And now we're going to color where the slope is negative, which seems to be in the other two sections. And here we have the negative part of this function. And this also occurs right at the end over here. So we have a positive, negative, a positive, and a negative section. And now the positive slope, these sections must be represented on the derivative function, must be above the x-axis here in this area, because the derivative function shows us the slope. Now, if the slope is positive, we need to have a look at the different sizes of this slope. At first, when you're looking at this, the positive slope is quite large, and then the positive slope decreases. I'll draw a smaller p, and it keeps on decreasing and getting smaller until it gets to 0. So we have a very high value of y decreasing down to 0. And this would look something like this, coming down until it's 0. Now what happens? We have a negative section, the negative slope. So now we come to our fourth point. The negative slope will be shown below the x-axis. But this section needs to be really examined carefully. When we had a look at the slope, and I'll bring this a little bit to view here, we had a negative slope over here, and you can tell that it wasn't a very steep slope. And then the slope began to increase, and it increased. Now, with this particular arrangement, it increased so far up to somewhere around there. That would be like the biggest increase. And then what happened is that the slope started to decrease again. And this decrease continued until it went back to 0. So unlike the first section, with the second section, we have increasing steepness of negativity until it gets to a maximum, and then it decreases again. And that's why we need to come back to our 0 here. The point at which the change happens is called the inflection point, and it's right here. and I'll draw a line down because at this point we will have the minimum here. So we can continue drawing our line down up to here to the minimum and back again to 0. In a similar way, the same thing happens in this part here where we've got positive slope, but the slope is going to be the steepest right in here where we have the point of inflection. And again, I can draw a little dotted line to there, and this is where our maximum now will occur. We've got to be on the positive side of the axis, so our line is going to go up and come back again to our 0. And after that, we continue showing the negative slope below the x-axis. So it'll just go down and it'll continue going down. We now have a function with a minimum and a maximum, and this type of function is called a cubic function. Let's not stop there. Let's find now the derivative of our cubic function. And this will be our double derivative now. So if you remember what we did, we actually draw another x-axis for this double derivative now. This will be our double derivative here. And we start with the first part, which was we determine where the maxima and the minima are. The maxima and the minima of the cubic function is now, this is the minima and this is the maxima. And we'll draw a line down to the next axis, and this will be our new zeros. And now we will color in the positive slope and the negative slope parts of the function. So this is our negative slope part, and this is going to be our positive side of the slope. And we come back to the negative slope of the function. Now remember that the negative slope will be shown below the x-axis. From a very steep negative slope, we come down to 0. Now we need to go above the x-axis because now we have a positive slope here. And that slope is positive, but it changes its steepness at that point. We called it the point of inflection. So we must go above the x-axis, but then we must come back to the x-axis 0. Now we're looking back at our negative slope, and we will have to show this below the x-axis. So our function should look a little bit like that. And this function, which looks like a parabola, is our quadratic function. Our quadratic function now has only one maxima in this particular case, and we can draw the derivative of this quadratic function as f triple x. And so we start by looking for the maxima or minima, and we find the maxima being here right at the top. And so we draw a line down to the next axis. And this is our next 0 over here. Now we have to color in the positive sides and the negative slope of that function. And our positive side is on here, on the left hand side. And our negative side will be on the right hand side of that maximum. And our rule says that the positive slope must be drawn now on the above the x-axis, and the negative slope must be drawn below the x-axis. But we have a 0 right here. And so our slope starts from there, and it must go down all the way up to 0. And then below the axis up to there. And now we have another function, and this function is called a linear function. And here we have no maxima and no minima, but this particular function, its gradient is negative and it's a straight line, and this derivative will be just a constant. If we show all the stages, we go from quartic here to a cubic with two maxima and a minima, to a quadratic with one maxima, and finally we end up with just a linear function. The shape of this quartic has a maxima, a minima, and a maxima, or it may have a minima, a maxima, and a minima. But there's also other quartics which don't have just maximas and minimas, but they also have points of inflection, as stationary points of inflection. So I would like to do another video on another type of quadratic function, quartic function, which looks slightly different. If this information was useful for you, then please subscribe to get my other videos and the next one. My videos are mainly for Mathematical Methods 12, 11, A level, and all senior maths.